right, let's go on page 78. We're going to do a really quick review of right triangle trig. We're not doing all of these problems, obviously, but I want to just make sure that we can all get the right things out of here. When we set up right triangle trig, what's our acronym to help us out? SOHCAHTOA. SOHCAHTOA. Okay, SOHCAHTOA. I know, you'll find out soon. That's coming in your near future. What to do if it's not a right triangle. Right now, all we know how to do is with right triangles. And again, this is a review from geometry. So here's my angle. This is the opposite side. This is the hypotenuse because it's across from the right angle. So which trig ratio uses opposite and hypotenuse? Sine. Thank you. So you always take sine, cosine, or tangent of what? The angle. Yes. So I'm going to take the sine of 32. That's equal to the opposite, which is 11, over the hypotenuse, which is x. Yeah, they do just flip. I'm going to go through the actual math one time just to make sure that we all understand why, and it's not magic. But so the math behind this is that you would multiply both sides by x. That's equal to 11. Then we divide by the sine of 32, so we get that x is equal to 11 divided by the sine of 32. So what happens every time when you have the variable in the denominator is that these two things just switch places. So it is fine to go from here to here. Just want you to understand it's not some sort of magic trick or anything. Then when you type it in the calculator, you get 11 divided by the sine of 32. Oh yes, make sure you are in degree mode, which these should be, and the D is really tiny up at the top. And if you're not sure if you're in degree mode or you're not in degree mode, then you do shift mode and then pick 3 for degree. That way if you can't tell if it's a D or not, if you just do that, then you know it's in degree mode. Okay, and we should get 20.758. You look okay? Okay. 20.758. And it says to the nearest thousandth, but if it didn't, then if it doesn't say, you go to 3 decimal places. We good? Make sure you're actually pushing the buttons and getting the numbers. All right. I love trig too. All right. So number 2, here's the angle. So this is the opposite. This is the adjacent. So which trig ratio is that? Tangent. So I'm going to take the tangent of 75. That's equal to the opposite, which is x, over the adjacent, which is 21. Then do I multiply both sides by x like I did on the other one? No. I multiply by 21, so I get 21 times the tangent of 75, and that's equal to x. Then when you push the buttons, something kind of interesting happens. What happens? You get a weird, exact answer, because you can get an exact answer on this one, but it tells us to round to the nearest thousand. So we want the decimal, so you hit the SD button, and you get 78.373. And there's no units on the triangle, so we're not going to worry about units on this, but if there were units there, that would be important. Okay, we all good? All right, y'all do number 3. All right, we all agree with that? What questions do we have? Anything? All right, do number 4, and then we'll move on to something else. Okay, any questions at all? We're all good? We're good, right? Quick, easy review. All right, so let's go down. That's finding side links. Let's talk about finding angles. So, given the trigonometric value of an angle, use the corresponding inverse trigonometric function to find the measure of the angle. So, if sine theta equals x, and I want theta, then theta is going to equal the sine inverse of x. That's how you undo it. We are not dividing by sine. The opposite of multiplication is division. There's not a multiplication here. The opposite of sine is sine inverse. So the opposite of cosine is cosine inverse. And the opposite of tangent is tangent inverse. No, that's the reciprocal and it's cotangent. The reciprocal and the inverse are two completely different things. Okay? So the reciprocal of sine is cosecant, but the inverse of sine is sine inverse. So reciprocals and inverses are different things. All right, so I want to find the measure of theta. And so I start off the exact same way. Here's the angle. This is the opposite side. This is the hypotenuse. This is adjacent. So which trig ratio are we using? Cosine. Thank you. So cosine of theta, because that's my angle, is equal to the adjacent, which is 18, over the hypotenuse, which is 23. You can't reduce that fraction, but even if you could, you don't care, so don't do it. What you want is theta, so that means that theta is equal to the cosine inverse of 18 over 23. Parentheses. Yeah, when you write it, you don't typically have to have parentheses, but I'm pretty sure it's going to open them for you in there, whether you want it to or not. It's not a power of -1. That represents the inverse. That's a completely different thing. The power of -1 would be the reciprocal, but that's not what this is. But that's not taking that to the power of -1. Because you brought it up. You said cosecant. Isn't that the inverse? And yeah, but anything to the power of -1 is the reciprocal. 2 to the power of -1 equals 1/2. It's the reciprocal. That is not to the power of -1. Cosine of theta, that would be to the power of -1. That would be 1 over, well, that wouldn't be 1 over secant. It would be secant. Sorry. It would be, hang on a second. It'd be 1 over cosine is what I was trying to get. So 1 over cosine theta is equal to secant theta. That has absolutely nothing to do with what we're doing here. See how this is in a different place? This does not represent an exponent. Yes. But you got to know those. Those are on your quiz on Friday. That is not what we're doing here. These are reciprocals. This is inverse. Again, two completely different things. Look, he's going to his notes because he doesn't believe me. This is good. Okay. He's using his notes. I'm proud. It's okay. So then this is opposite. This is hypotenuse. Which trig ratio are we using? Sine. Yeah, we made those up. That's what happened. So the sine of theta is equal to the opposite, which is 5, over the hypotenuse, which is 21. So theta equals sine inverse of 5 over 21. I was going to have you do that one on your own, but I got distracted, so I just did it. You said I was right? Oh, thank you. Those weren't the exact words. Well, what were your exact words, Michael? Have I ever lied to you before, Michael? Okay, and then these are degrees, so I do need to have those units on there because it's. Okay. Oh, and I'm guessing that we all got to the inverse just finally calculated, right? Because we're smart people and we figured it out. Okay, good deal. All right, flip it over. We're going to go to number 13. Okay, because this is just more of the angles, but you can do that. So this says solve each triangle. When you are told to solve a triangle, that means that you're finding everything that you don't already know. What would be the easiest thing, do you think, to find on number 13 that we don't already know? The angle. So angle B, 18. Because all I have to do is do 90 minus 72, right? And then this is 18 degrees. Well, that has nothing to do with the angle just yet. Okay, so here's the angle. No, this is the opposite. This is the hypotenuse. This is the adjacent. Yeah, with one side, you can't decide that. Okay. So I need to find both side lengths, and it doesn't matter which one we start with. Which one you want to start with? Adjacent. Well, we have that one. Good job, though. Okay, we'll go with opposite. So if I'm gonna have to use adjacent, do opposite. So we'll do tangent of 72 equals the opposite, which is the length of BC, of the adjacent, which is 15. Which means 15 times the tangent of 72 is equal to the length of BC. And that's what I got. Do we agree with that? Now, when we go to find the hypotenuse, I could use the opposite side that I just found, but I would have to store it, and you should always use what they gave you if you can, just so in case you did something weird, you don't, get things wrong. So we're going to find AB now, which means I'm going to use the adjacent hypotenuse, so that's cosine. So the cosine of 72 is going to be equal to 15 over the length of AB. So AB is equal to 15 over the cosine of 72. Uh-huh. That's fine. You get the exact same answer. The only danger when you use something that they didn't give you is that did you actually subtract correctly? And unfortunately, one of the most missed things on something like this would be this angle. Yeah, you know what I mean? Like if you got the angle, then you miss the whole thing. So that's, and it's not that y'all aren't smart enough to figure out that angle. It's that sometimes because it is easy, you don't use a calculator, you don't think about it, and you just subtract wrong and put something weird. You know what I mean? And then it causes everything to be wrong. But it's not, but what you did is fine. You'll get the same answer either way. Okay, we all good on that one? All right, let's jump to 15. So on 15, we're going to start by finding angle K. All right? And so this is the opposite side, this is the adjacent, this is hypotenuse. So I have the adjacent and hypotenuse. I'm going to use that to find angle K, so that's cosine. So the cosine of K is equal to 7.6 over 8, which means that the measure of angle K is equal to what? Cosine inverse of 7.6 over 8. I could have started with L, yes. I just picked K just because. Well, that's not what it is. And so you get 18.195, right? And now, we're going to do something that you don't necessarily have to do on this particular problem, but it's something you're going to need to be able to do on other things, so we're just going to go ahead and practice. In order to find angle L, I need to use the actual number that's in my calculator to do the subtraction. So we're going to store it. Again, I know you can do it without storing, but we're just going to practice. So you have the number looking at you, right? The 18, whatever. And then you're going to hit Shift, Recall, which is right above 7. And then the right parenthesis, which is that red X. Okay? You don't have to hit alpha or anything. And it's going to store it in X for you. So when you store and recall on this calculator, you don't have to hit alpha like you do on the other ones. Okay? And if you do, it's not going to actually store it correctly. So now if you hit clear and clear off your calculator, then you just hit recall right parenthesis, it's going to tell you what the X is. Does that make sense? So now to find angle L, just do 90 minus X. And it'll give you that number. Okay. And there's other ways to get around it so you don't have to store. But when you don't actually have to store, it's a good time to practice storing. Okay, because there will be things that you absolutely have to store when we get to it. This not being one of them, but it's a good time to practice. Okay, we all good so far? All right, so now I need to find JL. What are my options to find JL? I can do Pythagorean theorem. Could I do trig? Yes, and if I did, I would have to use a stored angle measure. Either I'd have to go ahead and store angle L, or I already have K stored, and I could use that one and do trig. But again, I don't need to. I can do Pythagorean theorem. So this would be 7.6 squared plus the length of JL squared equals 8 squared. But before I square anything or do anything, if I just go ahead and solve this for JL, JL is going to be equal to 8 squared minus 7.6 squared, and take the square root of it. And then you can type it in your calculator just like that. Work smarter, not harder. There's no reason to find all those pieces and write them all down and do all that stuff. Like, I have it solved for JL, type it in the calculator. You don't believe me?
No, that's why
That's okay. We do it all the time. That's right, but this has 2 terms in it, so it doesn't work that way. And you get 2.498. Do we all agree with that? And reasonableness of an answer, that's a lot smaller than 7.6 and 8, but does it make sense? Yes, because K is a lot smaller, right? So it should make sense. All right, any questions at all? Nope. All right, good deal.